All right, now let's turn to the existential quantifier rules for introduction and elimination, which correspond with the notions of existential generalization and existential instantiation we discussed earlier. On then to our rules for existential quantifiers. There are two of these, as there are for all, an elimination rule and an introduction rule. The elimination rule corresponds with the notion of existential instantiation, which we saw in last week's videos, and the introduction rule corresponds with the notion of existential generalization. Existential introduction is pretty straightforward. If we're moving along in a proof and we get a sentence affirming something of a constant, for instance that C is an S, then we're entitled to generalize and say that for some x, that x is an S. So something is an S. This is pretty straightforward. Existential instantiation, on the other hand, is a bit trickier. If we have a sentence like something is an S, then we can introduce a new subproof with a new variable that doesn't appear anywhere else. We'll box this, as we did with the variables in the universal generalization. So we'll say C is an S, and again, this C cannot appear anywhere else in the proof. Then, if in the course of this we derive a sentence Q, which does not contain any instance C whatsoever, then we're allowed to conclude Q by existential elimination. This one I think is one of the trickier rules, and so it's probably best just to see it in action in the course of a proof. In an earlier video, we saw this sentence: there exists an x such that for every y, y loves x. So everybody loves some one specific person. And we also saw that this entails that everybody loves somebody. So this will be our goal down here. For every y, there exists an x such that y loves x. Doesn't have to be the same x. In this case, this is a weaker statement than the there is somebody that everybody loves. Well, the first thing we do is we introduce a subproof and we replace our variable x with a new constant c. So we get there is a c such that for every y, y loves c. Again, we're not specifying what this object is. It's merely selected arbitrarily. Then we introduce a new subproof and we introduce a new constant d, again, which does not appear anywhere, and we eliminate the universal here. So we say that d loves c, and this is by universal elimination on 2. I'll number these lines. Now we perform an existential introduction on this and say that there exists an x that d loves. So this is by e-intro on 4. Well, this wraps up our subproof that we began on line 3 with the introduction of the arbitrary constant d for the sake of a universal introduction. So we can say on line 6, for every y, there exists an x such that y loves x. So this is by universal introduction on lines 3 to 5. It looks like we're where we need to go down here at 7, but remember that we started this whole thing out as an existential elimination right up here. So it's just a matter of closing out this one last subproof by existential elimination on lines 1 and 2 through 6. So there you go. There's how you go from someone is loved by everyone up here to everyone loves someone down here. And just remember that although the first implies the second, it doesn't work the other way around. Just because everyone loves some special person or other doesn't mean that someone is loved by everyone.